Most welcome student. Today we are coming the next type of the crystalline solid after the molecular solid, because we know that molecular solid are three types: polar solid, non-polar solid and hydrogen bonded solid. Now the second one, this is a covalent solid. They are constituted by atoms, it means covalent atoms, and atoms held together by covalent bonds, and they are forming gained lattice because covalent bonds are strong and directional, so that these solids are hard, high melting point and high enthalpy of fusion, like diamond. Now some covalent solid are a gained network, so they have a high melting point than ionic solids like diamond. In pure state they are insulator, and due to the non-available mobile electrons, but due to the impurities of some semiconductor, so they conduct electricity. For example, boron, carbon, black phosphorus, boron nitride, aluminum nitride and silicon oxides and silicon carbides are coming in covalent solids. After that we are coming in the ionic solids. Ionic solids is actually formed by cation and anions, and they have a strong electrostatic force. But remember that in a solid state they do not conduct electricity, but a molten state conduct electricity. Why they do not conduct in a solid state? Because they don't have ions. But in a molten and dilute and liquid condition they have ions, so they conduct heat and electricity. They are ionic nature, so they actually dissolve in water like sodium chloride. After that we are coming the metallic solids. Metallic solids are actually formed by the positive kernels and negative electrons. What is the positive kernels? Because we know that metal has highest atomic radii. It means weak intermolecular forces between electrons and atoms. So due to the high atomic radii, they are easily release electrons and they become a positive. The positive part is called kernel, and whatever the electrons they are released, they are deposited in interatomic space, and these electrons are called electron fluid or electron sea. So positive kernels and negative electron fluid have a strong intermolecular force, and this is called strong metallic force. Now again listen that metals have high atomic radii, so they are easily release electron and become positive. So positive part is called kernel, and the electrons released which are deposited in interatomic space, this is called electron fluid or electron sea. So that positive and negative things are produced, so they have a strong metallic force, so that they are malleable and ductility. Malleable, we know that they are changed in a thin sheet. Ductility, change into wire. Why? We know that they have electron fluid, and on hammering they change in a thin sheet, because the positive kernel are easily flow on electron fluid and easily change in a wire, so they have a malleability and ductility character. Now lustrous nature, lustrous means they give shining due to the presence of number of free electrons. They absorb energy and easily emit, so they have a lustrous nature. Now here I am write only two example of metal. This is iron and copper. This is the last type of the solid. After that we are coming in the next point. This is a determination of crystal structure or Bragg's law. WH Braggs and WL Braggs are used X-ray for determination of crystal structure, and this method is called X-ray crystallography, and they give the equation n lambda is equal to 2d sin theta. This is a Bragg's equation. Theta is angle of incident, d is distance between separating the layers, and n is integer number. If n is equal to 0 means equivalent to the reflection of light. If n is 1, then the lambda is equal to 2d sine theta and it is called first order diffraction. If n is equal to 2, then this is called second order diffraction. Now after that, on the basis of following diagram, we see that incident light are coming the left and reflected light is coming right. L and D is reflective light. The incident at O and N point. Then we know the distance between two layers is a D, so that N lambda show the MN diffraction and LN. LN, this is we know that perpendicular upon hypotenuse. Perpendicular is LN and hypotenuse is D. So ln is equal to d sine theta. Similarly, mn is the same. Perpendicular mn and hypotenuse is d. So this is also ln is equal to d sine theta. So n lambda is equal to 2d sine theta. In this way, we are coming the formula of Bragg's equation. After that, we are coming the numerical of this topic. If the monochromatic X-ray having of a 10.4 angstroms are preferentially diffracted by a crystal at an angle of 25.5 degree. Question is asking, assuming that this is the first order diffraction. So find out what is the distance. Here also already right. This is the first order, means n is equal to 1. Lambda is given 10.4 angstrom, means 10.4 into 10 minus 10. Theta is 25.5 degree. So we write the value. So D is coming 12.1 angstrom. And the second question are asking that if n is equal to 2, then find out the angle of diffraction, because wavelength we already know that this is given at 10.4. So angle of diffraction is actually giving 59.3. The next question, the interplanar distance of a crystal is 404 picometer. Calculate the angle of diffraction for second X-ray wavelength of 0.154 nanometer. N is equal to 2, D is equal to 404 minus 10 to the power minus 12, and lambda is given 0.154. So sin theta, theta is coming 0.3812. Question is asking that angle of diffraction. Angle of diffraction, we know that this is always 2D, means 2 theta. So this is 2 into 22.4. Clear? So this is the last question of the Bragg's equation. I am coming the next video with the next topic, but naturally this is actually topic is lattice point, lattice array, and so on. Clear? Thank you and thanks a lot.